Hello, I am Joey Walter, and welcome to my second project for ME 3210 in Dr. Hassan Rashidi's class. This project 2 will be looking at my air purifier improvements for design and manufacturing, and I'm taking this class in fall 2024 at Georgia Tech. So let's take a quick look at the agenda. First, we'll kind of break down the problem, look at the problem itself, the customer, and how the current product works. We'll go into my proposed solution with detailed sketches and CAD models to show what I'm thinking of. And then we'll look at manufacturing processes and materials I'm going to be using in my new design, as well as advantages and disadvantages and improvements for the user, and then the resources I used in my research. So description of the problem. Lifting heavy objects off the ground can lead to injury. OSHA has done lots of research and lots of surveying to really know this is a problem. And the higher up a person can lift from, the safer the action will be from off the ground. So adding handles can help with this issue. Looking at this graphic here, this is from the Department of Labor Services, we can see that most injuries happen, in the trunk, in the back. It's 42%, which comes from lifting objects off of the ground, and we see lots of sprains and strains. So sometimes milder injuries, but can go even further as we go down this list on the left. So let's take a look at the customer to kind of define the problem a little bit more, and the customer is me. I have a pretty severe sensitivity to dust and other allergens, which makes it difficult to sleep. I also live in the Atlanta area in Marietta, so I go home semi-frequently throughout the semester, and it's cumbersome to move this air purifier between Georgia Tech and my parents' home. So the air purifier is here, this Holmes air purifier. As you can see, it's just a straight, smooth cylinder, right? There's no handles, no place to grab. You just kind of have to clamp it, like in this image here. You just got to put your hands around it. It's almost slippery to lift with that clamping motion as well. And it weighs around 15 pounds, so it's not too light. So it'd be better if there was a solution to tackle this. So my proposed solution is to add a suitcase handle and wheels to the current design, as we see here. It allows for rolling, so you don't even need to lift it. We can avoid those, back injuries I talked about from the Department of Labor Services. Also, when in the collapsed position all the way down, the fan can be lifted if needed. Like obviously you're going to want to pick it up to put it in a car or on a shelf, so you'll also have that functionality. Now we'll kind of get into how I want to implement this design. So here's a detailed sketch. Over here on the left, we have the collapsed version. So here are the telescoping tubes on that handle of the suitcase design. And we have the inner tube inside the outer tube here. And then we can move into this extended version where the inner tube comes up and out of and locks in position at a higher height. And you can see by this black arrow that it goes both ways. Of course, you can collapse it and extend it whenever you need to. Going into the CAD model, we'll start with the telescopic poles. It's kind of like the most out of this design. So it allows the handle assembly to be in two positions, like I stated in that last detailed sketch that really showed that visualization, that it can be in a collapsed position and an extended position. In this screenshot, this is the collapsed. When it's in the collapse, it's 16 inches off the ground, basically fits into the footprint of where the fan is now. But when extended, it goes up to 30 inches, which is the perfect height to be dragging behind you and really allows you to be able to roll it around. It's also able to hold the 15-pound fan, so I was talking about in the collapsed position, you're able to just pick it up as well, and it'll be fastened to the fan with screws. Looking at the handle, we have the button up here on the top to transition between the extended and collapsed mode, just like a suitcase. Also this ergonomic hand-shaped grip pattern. I got this design from OSHA's and some government websites to be able to find that perfect outline. And then black color hides any potential scrapes or dirt as well. Looking onto the wheels and axle, so look at the wheels first. We have that inner fillet right here for ease of assembly. I really want to make this something that's easy to put together, and you can drive the axle right through the center. One wheel can support up to 25 pounds. Obviously with two wheels, 50 pounds is more than enough to support the fan. A solid center in the middle is to maximize structure and support so it doesn't collapse. And then down here we have an aluminum axle for weight bearing and smooth rolling. Finally, we'll look at the CAD model of the fully assembled system. So again, extendable up to 30 inches over here with the handles. The wheels run along the same axle for smoother control, so it's one long axle. And these telescoping poles in the back seamlessly transition, we see the curved feature here, into the outside of the fan, so it has that sleek design. So let's talk a little bit more about how this product is going to be made. So looking at the handle grip will be made with injection molding. It can create detailed geometries, especially ones that are more complicated like the outline of a hand, precisely and consistently. It also creates strong yet lightweight parts so you can lift from that handle. For the telescopic poles, we're going to be using hot extrusion. It allows for the required mechanical properties that I'll need with the yield strength and everything. And it's also good for long parts of consistent cross sections, which is exactly fits the description of our telescopic poles. Looking at the wheels and axle, so the wheel rims, like that inner full part, will be made through injection molding. Again, creates that strong yet lightweight part that can bear the weight of the fan, but minimizes additional load for the user when lifting it up. We have vulcanization used on the rubber on the outside of the wheels. This is just improve elasticity and strength of the wheels. And then for the axle, again, we're going to use hot extrusion because it's good for that consistent cross section. Required materials, so looking at the handle using ABS plastic, it's a durable material known for its impact resistance and toughness. It's also cost effective with high performance, so can take lots of loading. Aluminum we're using for the telescopic and telescoping poles and the axle for the wheels. It's strong, lightweight, and durable. It's corrosion resistant, which is important if we're moving in between locations and potentially outside. And it's also easy to process using hot extrusion. It's not like steel where you have to get it up to extremely high temperatures. Moving on to the nylons, this is like those inner wheel rims, another very durable material known for impact resistance and toughness, as well as high loading properties, which are super important when we might be picking this up and down. And then rubber on the outside of the wheels, it's very grippy, so when you want it to pull, it'll roll very smoothly, but when you want it to just be flat and stationary, it won't move very easily. And then rubber makes the wheels more maneuverable, able to turn a little bit better than other materials. The advantages is the most important part. So advantages include making the fan easier to move by rolling instead of lifting, mitigating those injuries. I added a handle to pick up from instead of just grabbing the outside of the fan. And the fan location is more customizable to maximize comfort from air purification because you can move it around. Disadvantages though, it does make the fan slightly heavier when lifted, just minimally though, and the fan may move more when meant to be stationary, but hopefully this will not be a big issue. Improvements for the user, more portable to maximize customizability, saves users from possible chronic or acute injuries caused by frequent lifting of the fan, and can be lifted from an ergonomic handle instead of a clamping motion on the outside. And lastly, its stability is unaffected with the proper care taken to maintain levelness in this design. Here are my resources. And thank you for watching. Disclaimer, this is for educational purposes only, no intended copyright infringement. Thank you.